Hey everybody, these are the notes for 6.1. Welcome to a new chapter. This is a different kind of thing than what we've been doing, at least for a little bit. So as we get started and you have questions, you know how to reach out. So in this section, we're talking about roots and radicals. So to begin, b, or a number, is a square root of another number if that number squared, the first one, equals the second number. So for example, 2 is a square root of 4 because 2 squared equals 4, right? 2 is the square root of 4. So identify the square roots. We're going to blow through these really quick. What is the number squared that makes 25? Well, it's 5, right? What's this number squared that makes 49? 7, right? What is the number squared that makes 0? Well, that's a weird one, isn't it? It's just 0 because you can't hurt it, right? No matter what you do to 0, you still have 0. What is the number squared that makes -9? Well, there isn't one, right? So in this case, the answer is none, because if I do -3 times -3, I get 9. And if I do 3 times 3, I get 9. I can't get to -9 by squaring a number, by multiplying it by itself. All right, so you do these real quick. Okay, should be 8. What's that one? 4, 1. And this one, again, the -100 is a giant none. All right, see, so far so good, right? So if a represents a positive square number, then the square root of a is the positive square root of a. This is also called the principal square root. If I have a negative in front of that square root, it's the negative square root of a. And keep in mind that no matter what I do, the square root of 0 always going to be 0. So let's see how this works. Identify the square roots. This is just a different way of asking the same question we asked a minute ago. So for this one, the principal square root is 6, isn't it? Okay. What's the square root here? Well, just take it in pieces, right? The square root of 4 is 2. The square root of 9 is 3. Look at this one. What number do you have to square to get 0.04? Well, that's 4. 4 squared is 2, so there's got to be, or sorry, 2 squared is 4, so there's got to be a 2 in it, and it's actually 0.2. You guys have calculators. You could figure this out that way. Then try these. The thing to remember about using your calculators is you should try to use your brain first, right? Because I know the square root of 81 is 9. I didn't have to calculate this. And honestly, if I put 36 divided by 49 in the calculator and take the square root of that, I'm going to get some crazy decimal. But I didn't need to do that because I know the square root of 36 is 6. I know the square root of 49 is 7, and I'm done. I can leave it that way. I don't need that decimal form, so don't feel compelled because I'd rather see this fraction that shows me that you can pick out the square root. For the last one, it's 0.3. If you do that in your calculator, no one will die. All right, simplify the square roots if possible. So here's the thing, just like we were talking a bit ago with -9, we don't have a number that's squared to get to a -9, just like I don't have a number that's squared to get me to 144. So the answer to this is that there is an answer, actually. I can take the square root of a -144. I just can't take it yet. So for now, and this is for now, because by the time we get through the end of this chapter, you will have a different answer. For now, because we don't have that additional tool yet, the answer is that this is not a real number. And what you should write is not real. I can't take the square root of a negative number. It's not a real number. Eventually, we'll get a new kind of number that can solve this for us, but we're not there yet. How does this one go? Now think carefully, because think about order of operations. Technically, what's happening here is that. So I can take the square root of 144, it's 12. And then on the front, I have a negative. So the answer here is negative 12. The next one, how does this one work? This is another not real because the negative sign is inside of the square root. What about this guy? Well, let's simplify the square root first because really we're talking about this, right? So the square root of 1 is 1, the square root of 9 is 3. I have that negative out front, so the answer is negative 1/3. Let's try these real quick. Square root of negative 81, it's definitely not real. The square root, negative square root of 64 should be negative 8. The negative square root of 0.25 should be negative 0.5. And the square root of negative 1/4 is again not real. Pay attention to where the negative sign is in each of these. It matters. Okay? All right. So we can take more than square roots, right? B is an nth root, whatever kind of root I want, a cube root, a fourth root, a fifth root, a whatever root of A, if B to that root equals A. So 2 is the square root of 4 because 2 squared is 4. 2 is the cube root of 8 because 2 cubed is 8. 2 is a fourth root of 16 because 2 to the fourth is 16. 2 is the fifth root of 32 because 2 to the fifth is 32. Okay, we can carry this through. The other important thing is that when we evaluate nth roots, some of them can't have a negative inside the square root. Some of them can, because we think about what a root means. That n tells me how many times I can multiply something together. Okay, so if I have negative 2 times negative 2, I get 4. No matter what I do, there's no way to do that. But if I add in one more negative 2, I multiply it in, negative times negative is positive, negative times positive is negative. I'm going to get a negative answer, which means a negative under the radical is okay if it's an odd root. So if n is greater than 1 and an even integer, and we're using n as our exponent, remember, then the nth root of A is the principal root is the nth root of A. It has to be positive, right? If n is less than 1, or n is greater than 1, pardon me, and odd, the nth root of A is the nth root of A. So if I have the cube root of 8, I can have the cube root of 8 as 2, and I can have the cube root of 8 is negative, or too many words. The cube root of 8 equals 2. The cube root of negative 8 equals negative 2. If I took the square root of negative 9, that would be not real. If there's an even number here for the root, the answer is not real if there's a negative under the radical. If it's odd, like a 3 or a 5, I can do that. The nth root of 0, still going to be 0. All right, simplify. So what's the square root of 4? Square root of 4 is 2. What's the cube root of 64? Now think for a second. You need to multiply something together. What this means is x times x times x equals 64. All right. The cube root of 64 is actually 4. So as I think I said at some point, it's useful to have the perfect squares and the perfect cubes in your head or on a list in your notebooks somewhere, okay? The fifth root of negative 32. Now, I know that the answer here is going to be real because this 5 is odd. So this is totally okay. So it's going to be a negative answer. I need to multiply negative something times negative something times negative something times negative something times negative something 5 times. The answer here is negative 2. The fifth root of negative 32 is negative 2. The fourth root of 81. So again, what this means is something times something times something 4 times is 81. What's that something? Well, that something is 3, okay? You should be able to figure this out. Use your calculator, make a chart, do what you need to do. The 6th root of 1,000,000. So something multiplied together 6 times gets me 1,000,000. In this case, it's 10. All right. The square root of -100. So it's an even root with a negative underneath. That is going to be not real. All right. The 4th root of -16, again, an even root with a negative underneath, not real. This, if it was a 5, we could talk, but it's not. It's even. All right. Take a moment and go through these. Push pause if you need. I'm not going to go through and answer them here. If you have questions about them, please drop yourself into the chat. Not the chat, the discussion. I keep saying that. And I'm going to write myself a note that I need to drop in there today. And check in for the answers. Get some help if you need it. All right. So if n is a positive odd integer, then the nth root of a to the n is a. So what this says is that if I take the square root of a squared, I get a, okay? If I take the 4th root of a to the 4th, I get a, okay? Oh, sorry, odd. This one applies here. Give me a second. We'll talk ourselves backwards. Let's do number 1 first. Let's do it in a different color. So the 5th root of a to the 5th is what we're talking about. It's just a. The cube root of a cubed is just a, okay? If it's a positive even integer, I take the absolute value of it, okay? So the square root of a squared is whatever the absolute value of a is. So if it was the square root of -2 squared, these guys cancel themselves out. The answer is going to be 2. Absolute value of -2 is 2. Remember, absolute value is distance from 0, right? So this guy is even, right? The 4th root is an even root. That means the answer is going to be the absolute value of -3, which is 3. This guy is odd. 5th root is an odd number. That means that the answer here is just the number that's in there, -3. What about this one? Don't overthink this. You don't have to square anything. The square root and the squared negate each other. They cancel each other out. So the answer here is just x plus 2. Oh, pardon me, the absolute value of x plus 2. Okay. These are cube roots. They cancel each other out. So the answer here, because they're odd, is just a plus b. This one is the square root of y to the 4th. Now think about that for a second. How do you think this is going to work? The square root of y to the 4th. Well, what thing times itself? I have to do something, some number times something gets me y to the 4th. How do I get that? Well, it's y squared, isn't it? These are even, the squared and the 4th. The square root in particular is the one that matters. So the answer is going to be the absolute value of y squared. All right, go through and try these and find your answers. If you need help, you know where to go into the discussion, onto your messenger. Do what you need to do. All right, let's try this one. So this one, how do we think about it? It's the square root of y to the 8th. So again, I'm thinking about what times what gets me y to the 8th. Well, when we have exponents and we are multiplying, we add the exponents, right? So I know that y to the 4th times y to the 4th gets me y to the 8th. So my answer is the absolute value of y to the 4th. Okay. This one is crazy. This one has 2 parts. This is a cube root, right? So no absolute value needed. So I'm going to actually think about it in steps. I know the cube root of 27 is something times something times something makes 27 is going to be 3. The cube root of a is just, or sorry, cube root of a cubed is just a. So the answer here is 3a. This one is the 5th root of a to the 5th divided by b to the 5th. So look at them in pieces, right? It's an odd root, so I don't need an absolute value. The 5th root of a to the 5th is just a. The 5th root of b to the 5th is just b, so I have a over b. Oh my goodness, this one's crazy. So ignore the negative. We'll just leave that out here in front for our answer. And let's take the 4th root of a piece at a time. So the 4th root of 81, and I'm going to take the absolute value of my answer because it's an even root. The 4th root of 81 is 3. The 4th root of x to the 4th is x. The 4th root of y to the 8th is y squared. The 4th root of 16 is 2. All right, so then my final answer over here is I have to take the absolute value of that. There was nope, the negative wasn't on the inside. I would be taking the absolute value of this, pardon me, and then the negative applies. So it really is negative 3xy squared over 2. So remember, in order of operations, let me put my parentheses in the right place, okay? So that was my operation here, right? I would be taking the absolute value of this because it's the 4th root, and the negative is out front. So the negative isn't applied to the absolute value, it carries to here. All right, here are a couple for you to try. Again, if you are stuck, if you need help, you know where to go, okay? Be very careful to make sure that you can do 25, 26, and 27 here. They are important. They lead us into the next thing. So if you are stuck and you're going to ask about anything, these are the ones you should ask about. All right. So let's use the Pythagorean theorem. Remember, a squared plus b squared is c squared. We just did that fairly recently. And find the square root, the principal square root, the positive square root for the unknown side. Well, I know a, b, c, 5 squared plus b squared equals 13 squared, right? 25 plus b squared equals 169 minus 25 from both sides. I get b squared equals 144. Well, I know if I take the square root of both sides, b is 12. It could be negative 12 too, right? Negative 12 times negative 12 is 144. But like, that's not a length. I would be using the principal square root here, so it's 12 feet. You try that one when you have a second. All right, same idea here. 2 boats leave a dock at noon. One travels north at 6 miles an hour. The other travels east at 8 miles an hour. Okay, so they traveled for 2 hours. How far apart are they after 2 hours? So they travel, this guy travels this way. This guy travels 2 hours that way. How far apart are they? Well, Pythagorean theorem again, right? 12 squared plus 16 squared equals c squared. 144 plus 256 equals c squared. 144 and 256 are 400. Square root of both sides. And it only makes sense to use a positive 20 here because I don't count miles. I don't say, well, it's negative 20 miles from here. You guys would think I was crazy. Probably think I'm crazy already, but I'm okay with that. All right, this is the same. You just need to draw the picture for this one. 2 cars leave the same place at the same time. One travels west at 40 miles an hour. The other travels north at 30 miles an hour. There are 2 hours on traveling. So I want to know this distance c. This guy in 2 hours, he has gone 80 miles. In 2 hours, the other guy has gone 60 miles. You guys got to find what's in between. Do your best. All right. N, there's another definition in here. If n is an integer greater than 1 and the function is written in this form, f of x equals the nth root of x. This is called a radical function, okay? It's just the same thing we've been doing. We're just going to give it a more official name, okay? So what a radical function looks like is this. We need to be able to write the domain and the range. Oh, just the domain here, pardon me. The domain tells me, okay, what's acceptable to put into this answer. The first thing I need to think about is the root. In this case, it's even. So whatever I get has got to be greater than 0, okay? So what I'm going to do is I'm going to take whatever's out from under the square root, and I'm going to say t minus 2 has got to be greater than 0, right? So plus 2 to both sides. T has got to be greater than equal to 0, which makes sense because if I put in, oh, greater than equal to 2, my brain is broken. Sorry. If I put in a 1 here, 1 minus 2, and I take the 4th root, that's not going to work very well, is it? I'm going to get a negative. I can't have a negative under an even square root. That's not real. So we get problems. But if I put anything from 2 up in underneath that radical and solve it, it's going to work out because I'm going to have a positive number underneath the radical. It may not be pretty, but it'll work. Okay? So now I'm going to write this domain in interval notation. Okay, so it's got to be at least 2, and it can be 2, so 2's included. Okay, gives me a hard bracket. And it's going to go all the way up to infinity from there. All right, let's try another. This one is an odd square root. So I can have a positive number under there. I can have a negative number under there. I can have anything I want. What that means when I have an odd square root is that all real numbers will work. I don't have to do any work with the domain when it's an odd root. The only time I really have to think on it is when I know it has to be positive under the radical. All right, this one is weird, right? So what really matters is what's under the radical. So I'm not even going to worry about this 2 at the moment. This is an even root, so I know the answer has to be greater than 0. So I'm going to solve for x. So I get negative 5x is greater than or equal to negative 3, divide by negative 5. So x, remember when I divide by a negative, the sign flips, has got to be less than 3/5. It can be equal to 3/5, but it's got to be less than or equal to 3/5. Remember when we divide by a negative, interval signs switch. So think about where x is less than 3/5 are. Okay, so I'm going from negative infinity to 3/5, and then I'm going to stop. That's the domain here. All right, here are a couple for you to try. Please try them. Write your domains in interval notation. If you need help with that, you should ask. All right, let's try another one. Let's try this one. Write the domain in interval notation. So it's an even root. That means that what's underneath the radical has to be greater than or equal to 0. So I'm going to add x to both sides. I get 3. X plus 0 is just x. So I can actually flip these so I can read them right if I want. X has got to be less than or equal to 3. Okay, so x has got to be less than or equal to 3. That means from negative infinity up to 3. Okay, now I want to graph it. Well, how do I do that? I can make a little chart, ordered pairs, right? I know x has got to be less than or equal to 3. So maybe the biggest thing I can put in is 3. So let's count backwards. Let's see. If I put a 3 in there, I get a 0. So the square root of 0. So look what I'm going to do. 3 minus 3, square root of 0 is 0. If I put a 2 in there, 3 minus 2, square root of 1 is just 1. Okay. If I put a negative 1 in there, I don't really want to take the square root of 2. Let me use something. Let's do a negative 1. So 3 minus negative 1, that's much nicer, is 4. Square root of 4 is 2. Okay, and let's try one more. Maybe let's, negative 6. So 3 minus negative 6 would be 9. Square root of 9 is 3. So now you graph. You know how to graph. X-axis goes left to right, right? Y-axis goes up and down. So over 3 to the right, not up at all. That's 3, 0. Over 2, up 1. Over left, negative 1, up 2. And over to negative 6, 1, 2, 3, 4, 5, 6, and to negative 3. So there is my graph. Okay, you try this one. This one should work very similarly. Check the notes as you need them. This is the end of section 6.1. As you have questions, you know what to do. I'll see you in the next section.